Hey guys, in this one we're taking a look at sketching Quartic functions. Now these are the guys with the highest powered X term has a power of 4. So if you haven't watched the two previous videos in this playlist, I highly recommend going back, checking those out. In the introduction I go over the general shape of a Quartic, and in the cubic video we talk about distinct double and triple roots and what they do in terms of the graph and the x-axis. So I don't like repeating myself, so I'm not going to go over that again. Go back, check that out. So let's have a look then. Okay, so our first example, y is equal to x times x plus 1 times x minus 1 times x minus 3. So this is a quartic. If we were to expand all of this out, we would get an x to the power 4 term. It's highly unlikely that you would ever be given a quartic in expanded form and then have to factorise it, because oh my god, that's going to take a long time and it'll be very impractical under exam conditions. So I'm pretty confident whenever you see these, they will always be in factorised form. So let's first of all think about what the y-intercept would be. So if we were to expand all of this out, we would get no constant term at the end. This x at the start would multiply the 1, the minus 1, and the minus 3, which would give us an x term at the end. So there's 0 constant at the end. That means the y-intercept is going to be 0. Okay, then we need to work out whether or not the x to the power 4 term is positive or negative. So we would have x times x times x times x, which would give us positive. So we'd have a positive x to the power 4 term. Now what that tells us is our graph starts in the top left and ends in the top right. So that's good. And now we need to work out where this graph hits or crosses the x-axis. So the x gives us x equals 0. X plus 1 gives us x equals minus 1. X minus 1 gives us x equals positive 1, and x minus 3 gives us x equals 3. So we now have all the information that we need to sketch this guy. So let's do just that. Okay, so there are my axes. So we know them. The graph starts in the top left. Now the first place it hits the x-axis is at minus 1. So it's going to do something like this. It goes back up, crosses the x-axis at 0, 0. Crosses the x-axis again, positive 1, and then once more at positive 3. So it's going to look something like this. Just make sure you label the points. So this guy is 3, 0. This guy is 1, 0. This guy is 0, 0. And this guy over here is minus 1, 0. Now you'll probably get away there with just labelling the x values, but just to be careful, I'm labelling the full coordinates. Okay, there's our first quartic sketched. Good times. Okay, example 2, so this time we have y equals 1 minus x times 2x plus 1 times x plus 2 times x minus 5. So, let's first of all work out the y-intercept. So, we get that by multiplying all the constants together. So we got 1 times 2 times minus 5. Now that is going to give us minus 10. So our y-intercept is minus 10. Now, is our x to the power 4 term positive or negative? Well, we've got minus x times 2x, which is minus 2x squared, then times x, so we got minus 2x cubed, times x again, minus 2x to the power of 4. So, this time we have a negative x to the power 4 term, so our graph starts in the bottom left and ends in the bottom right. Now we need our solutions. So, 1 minus x, remember to get your solutions each set, whatever is inside each bracket, equal to 0, and then solve for x. So 1 minus x would give us x equals 1. 2x plus 1 would give us x equals minus 1 half. X plus 2 gives us x equals minus 2, and then x minus 5 gives us x equals positive 5. So again, we have 4 distinct roots here, none of them are repeated, so the graph crosses the x-axis at all 4 of these points. So, we've got all the info we need now. We can sketch. So, what's our first solution on the left? It's minus 2. So, we also need to remember our y-intercept here is minus 10. So we're starting on the bottom left. We come up, we go through the x-axis of minus 2. We go back through at minus 1 half. Then we go through the y-axis at minus 10. We go back through the x-axis at positive 1. So something like this. And then again through x equals 5. So our graph looks something like that. So our leftmost point is minus 2, 0, and then we have minus a half 0, then our y-intercept is 0, minus 10, then our next x-intercept is 1, 0, and then our final x-intercept is 5, 0. Like that. Good times. Okay, example 3, we've got y equals x minus 1 times x plus 2 cubed. So, we have a distinct factor, x minus 1, and then a triple factor, x plus 2 cubed. So this Quartic is only going to cross the x-axis twice. So, let's first of all think about the y-intercept. So the y-intercept, well, that's going to be minus 1 times. Now, if we were to expand this, we'd be doing x minus 1 times x plus 2 times x plus 2 times x plus 2. So we'd get minus 1 times 2 cubed. So minus 1 times 8 gives us minus 8. Now, we're going to get a positive x to the power 4. So it starts top left, ends top right. And our solutions, or our x-intercepts, are x minus 1 tells us x equals positive 1. X plus 2 cubed gives us x equals minus 2. So we have all the information that we need to sketch this graph. We just need to think about what's going to happen at x equals minus 2. So it's a triple root. So what's going to happen is, as the curve approaches the x-axis, it's going to sort of slow down a bit, and then it's going to hit the x-axis, and then it's going to be gentle, but then speed up quite quickly. So, to show you what I mean by that, it's easiest just to do it. So if you think about just the graph of y equals minus x cubed, it's going to look like that over x equals minus 2. So it's going to sort of do this. And then it's going to go down, hitting the y-axis at minus 8. Something like this. So this point over here is minus 2, 0. This point down here is 0, minus 8. And then this final x-intercept is 1, 0. So it's completely not to scale, but it doesn't matter in your sketch as long as you label the important points. Okay, next up we have y equals minus x plus 2 squared times x minus 3 squared. So we got 2 double repeated roots here. So what happens at a double root is the graph touches the x-axis but does not cross it. We also have to be very careful here because we have a minus at the start. So let's talk about the y-intercept first of all. So if we were to expand x plus 2 squared, we would get a 4. Now remember, we got this minus at the start, so we can get minus 4 times, and then if we expand the second bracket, we would get a positive 9, so we get minus 4 times 9, which is going to give us minus 36. Now, is the x to the power 4 term positive or negative? Well, in the first bracket, we would get an x squared. In the second bracket, we would get an x squared. So x squared times x squared is x to the power 4, but then that negative is affecting that term, so we actually get a minus x to the power 4 term. So we've got a negative graph. And then we just need to think about the solutions. So x plus 2 squared would give us a double repeated root of x equals minus 2, and x minus 3 squared would give us a double repeated root of x equals 3. So we've got all the info we need. So, because it's a negative x to the power 4 term, we're starting on the bottom left. Now we're going to go up and hit the x-axis, but not cross it, at -2. Then we go miles down to -36. Then we come back up, hit the x-axis at +3, and then go back down to the bottom right. So this point here is 3, 0. This point down here is 0, -36, and then this point up here is -2, 0. So there's our sketch. Good times. Okay, final example for this video then. So this time we've got 2 distinct factors and 1 double factor. So we've got y equals x plus 2, x plus 3, x minus 1 squared. So the y-intercept is going to be 2 times 3 times -1 squared. So 2 times 3 is 6, -1 squared is 1, so we get 6. In terms of the x to the power 4 term, we get x times x times x squared, so we've got a positive x to the 4. So our graph starts top left and ends top right. Now we just need to find the solutions for the x-intercepts. So x plus 2 tells us x equals -2. X plus 3 tells us x equals -3. And then x minus 1 squared gives us a repeated double root at x equals 1. So what's going to happen there? The graph is going to touch the x-axis at 1, but not cross. So our graph then is going to look something like this. So we're starting in the top left, we cross at x equals -3, and then again at x equals -2. So something like this. We cross the x-axis, the y-axis at 6, and then we come back around and we hit the x-axis at 1, but we don't cross. So it's going to look something like that. So this is 1, 0, this is 0, 6, this guy is -2, 0, and then finally this guy over here is -3, 0. So that is our final sketch of a Quartic. Okay guys, hope you found this useful. If you want any more examples or have any questions, let me know down below in the comments. For now though, take care.